Diksha. Let's now hear from Aishwarya Mittal, who will share how OpenTelemetry can revolutionize signal implementation for better observability. Aishwarya Mittal, Senior Engineer, American Express.
Hello everyone, welcome you all to the lightning talk on signal implementation through OpenTelemetry. I'm Ishwarya Mittal, working as a senior engineer at American Express, and I love to build and develop the innovative solution. Looking at the journey of the American Express, we have grown stronger and providing the best-in-class customer experience. Talking about the today's agenda, we will be covering about what is observability, what is OpenTelemetry, and why it is needed. What are the different components involved in the OpenTelemetry? And followed by the different various instrumentation available in OpenTelemetry. Last but not the least, we will look at how we can configure dashboard and alerting. As a tech enthusiast, we are constantly striving to achieve a better observability, reliability, and performance in our system. Have you ever wondered how we can harness the power of data that can drive insights? So isn't it interesting? Let's know about it. The observability is a technical solution that allows you to become the Sherlock Holmes of your system, as it will help you to pinpoint and understand the application operation by pinpointing what, when, and why the application is not behaving as expected. It focuses on three types of telemetry data that is widely known as three pillars. Logs. Logs records an event of an application with a timestamp. It helps to understand the unanticipated behavior of application. Next, we have traces. Traces outlines the activity of the request and the path it takes through the entire application. It is a prime component as it is a first stop when debugging any issue or during the outages. Thirdly, we have metrics that represent the numeric data about infrastructure or the application. It could be the response time, availability, system errors, P90, P95, etc. So observability gives you the benefit as it helps to cut down on MTTR, resulting in shorter outages and better application performance. Now moving on, that we have an OpenTelemetry. So OpenTelemetry is an observability framework and a toolkit that is designed to create and manage the telemetry signals such as logs, traces, and metrics. It is an open source project hosted by Cloud Native Computing Foundation. And it is originated through a merger of Open Sensors and Open Tracing project. It is the second largest project just behind the Kubernetes. OpenTelemetry bridges the gap between the legacy monitoring system as it will help us to understand and fix those issues that are negatively impacting our application, thus to have a better reliability and better performance. So you must be wondering, why do we need the OpenTelemetry? In an existing system, the logging is weakly integrated with the rest of the telemetry signals, as there is no standardized way that it can propagate and provide you the context execution path. So in a world of distributed system, it results in a set of disjoint sets collected from different components. So how these different components know about each other? As you can see here, that there are different log collection agent that is being used, and it uses the different protocol, different libraries. So all of the data is being collected at the different backend, but that does not know how to work well together with each other. So that creates a problem. Now, OpenTelemetry, on the other hand, provide you the solution for all of these problems, as it standardizes the log correlation with the traces and logs, provide you the additional benefit of distributed context propagation. Last but not the least, it provides you the unification of source attribution of logs, traces, and metrics. So here you can see that all the logs, traces, and metrics is collected by the OTel collector, that is collected at the separate backend, but they do know that how they can work together with each other. From one component, it is easier to identify the other. To understand, let's understand the OpenTelemetry components. So first prime component is APIs. These are the primary component and describes the data operation of the logs, traces, and metrics. It is language specific. Next, we have SDKs. SDKs take care of sampling, required processing, and then it will emit the data to the OTel collector. OTel collector itself has a different components within it. So we have a receiver, where it will take the data from open source like Prometheus, Agar, and n set of applications. After that, it will send it to the processor, where it can be the multiprocessor can be used. So it performs the intermediary operation like adding the metadata. Then we have an exporters. Exporter emit the telemetry data to a backend configuration, and it decouples the instrumentation from the backend configuration itself. So it makes it easier for the application to switch the backend without re-instrumenting the entire code. OTLP is the protocol that is being used within that. So OTLP helps in defining the encoding, delivery, and transport mechanism of telemetry sources between the initial source, intermediary operations, and the backend data. So to know that how we can instrument OTel instrumentation, there are two ways, either the manually or automatic. So in a manual instrumentation, we will first go through the logging part. So in the logging, all you have to do is, it uses a direct-to-collector workflow. That is very easy, as it does not require any additional log forwarding component. And it allows the application to emit the logs in a very structured format. We will see in a minute. To install the OpenTelemetry SDKs, what you have to do is, first install the OpenTelemetry appender, either logback or log4j. Apart from that, then you have to configure the OpenTelemetry log SDKs to emit the log to a particular destination or the backend. So there we have a log processor that uses and processes the log emitted by the log appender. It can be done in two ways, either the batch processing or sample processing. In batch processing, it periodically sends the batches of log record to a log exporter. However, in simple processing, it immediately sends each of the log record emitted by the log appender and to the log exporter. So the log exporter works well with the simple batch processing or the simple processing or batch processing. It can either use gRPC or HTTP. However, gRPC is preferred one, as it is much more faster than HTTP. So how the log structure will look like, as you can see, it is very structured. It will provide you the information about your service, environment, what are the different messages, and then it will also have the additional details, which will be useful for identifying the issue and what is required when the application takes that particular request. The another component that we have is a tracing. So tracing introduces a concept of context propagation in OTel. So to understand what is context propagation, let's first understand the word context. So context means it is an object that contains the information about the sending and receiving services that can be associated with each other, and we can attach it to a trace overall. So let's say if your service A is interacting with the service B, but the path of the entire request is considered when the service moves from service A to service B. So the span or the unit of operation that is done in a particular area is taken care by the span A, and that will be propagated to the service B. So the propagation means it is a delivery context of moving an object from different services. So it takes care of serializing and deserializing the object and provide the relevant trace information. So in order to configure the log tracer SDK, you have to configure the trace providers. So the trace providers, its life cycle matches with the application life cycle, and it is initialized once your application gets started. So here again, the trace provider initialization involves the span exporter and the resources initialization as well. So here you can see that there is a make deposit function, the API is being called in ATM service, which has a span ID. So it represents a unit of operation that is being done. And similarly, it calls another service accounts where another span ID is being generated. And both of these span IDs is associated with a trace ID overall. So it will give you the entire request journey that will be very beneficial in debugging and identifying the issue at which service the application is not behaving as expected. With the tracing, there is an additional benefit that you can add the additional information in your spans with the help of tags. It represents in the key value pair, where you can add the information that is relevant for a unit of operation or required for the request. However, we always wonder and we always think that if there is a way that we can pass an information from service A to service B, because the customer information identifiers will remain the same throughout the entire request journey. So that can be done with the help of the baggage that represents a uniform way of storing and retrieving the information. So here you can see that we have the parent ID, that is a span ID is mentioned, and within the context field, we have the trace ID and span ID that represents of child. But the trace ID is represented for the overall log. Even we can add the additional attributes like I mentioned, so the HTTP route and some route value is being added. Here, there are different events also can be added across it. In order to do the automatic instrumentation, it is a zero-code instrumentation. Here, there are two ways in Java where you can use the agent collector or the Spring Boot starter. Java is my favorite coding language, so here I've taken this example, but automatic instrumentation is available for different set of languages. Through agent collector, what you have to do is, it will dynamically inject the bytecode in your application that will capture the telemetry data at the edge of the service or the application. So it will take care of inbound, outbound, as well as the database calls. All you have to configure its path either using the system properties or the environment variables. The another way is the Spring Boot starter. It is beneficial for those areas where the OTel jar does not work well, like the Spring native image application. Or it will take care of doing the overhead installation of the OTel jar. Even the Spring Boot configuration files work well in initializing any of these OTel configurations. So if you want to do the annotation base, it can be done with the help of the programmatic configuration that is there with the Spring Boot. And if you see here, the data will look like, similarly, here two spans are being called and it is shown by the different color encoding. in order to configure the dashboard and alerting, there are different visualization this is possible, either using the statistic tables, time series chart, or the histograms that will depict or represents your metric. And alerts are very beneficial in identifying if there is a spike or anomaly that is being detected. So you can do it either using the open source alert, that will be a UI-based alert, and another way is an Elastic alert that will take the sample YML file as an input, and it will help you to write the complex queries. So now looking at the dashboard, here we have the different dashboard created. You can see that we can have the overall availability, as well as we can define it by the function name, data centers, what is the status, is it success, business errors, etc. So whenever there is any spike or whenever there is a drop in the volume, the one can take the proactive measure in resolving the issue. Then and there, thus we can save ourselves from having the major outages. This is the benefit of having the OpenTelemetry in place in our application. Thank you everyone for joining in. If you have any question, do let me know.
Thank you for sharing such actionable insights. I'd like to invite the session chair to present a token of appreciation to our speaker.